Okay, so let's discuss the next important component of the system design, that is load balancer. So to understand the role of the load balancer, let's take a simple example. Let's say we have developed a simple ticket booking application and we have deployed that onto a server with this configuration, that is with 4 GB of RAM and 2 virtual CPU. So in general, if we go theoretically, with this configuration, we can have around 15 to 20 concurrent requests. That is, we can have 15 to 20 people concurrently doing some booking on our application, right? So that's in a normal scenario. But now let's say because of some event or some movie got hit, the number of users got increased and the number of concurrent requests moved from 20 to 100 or 100 to 500. So now in this case, as we know, definitely the server will fail because the amount of RAM required for so many concurrent requests and the number of threads needed will be significantly higher than the current server, right? So that is where the server will get failed. So now in this case, the one of the option which we can have is the horizontal scaling, right? So when we scale our server horizontally, that is, we will keep the same configuration of the server, but we will increase the number of servers, right? So now instead of one, we will have 3 different servers, right? So now when we have three instances of the same application, so now in this case, we need a component or a system that will make sure the load will get balanced among these 3 servers. So this is where the load balancer comes into picture. We will apply a component that is load balancer. I will show you a demo of this at the end of this video. So we will apply a load balancer. So now whatever the requests will be coming from the users, that will first hit the load balancer, and now the load balancer will decide on the basis of the algorithm which we have chosen. On that basis, it will distribute the load. So we'll discuss the algorithm next. So basically here all the requests will be hit to the load balancer. Now the load balancer will distribute those requests among these servers. So now as we have 3 different servers, so now automatically the number of concurrent requests our overall application handles will get increased. So from now 20, 15, 22, now we can definitely able to handle around 60 to 80 concurrent requests, right? So that's the difference when we have a load balancer and when we don't have the load balancer. Okay, so next let's discuss about the load balancer algorithms. So here we have different algorithms that can be configured or that can be selected when choosing a load balancer. So first we have is the round robin. So when we select the round robin as the algorithm for our load balancer, then the load get balanced in a sequential manner. That is, it will first hit the first server, then the second request will hit the second one, and the third will hit the third one, and then the fourth one will again go back to the first. So it just distribute the load in the round robin fashion. So that's a very simple algorithm. Next we have the weighted round robin. So in the weighted round robin, it's act like a round robin, but the only difference here is that the load get distributed on the basis of the weights of the server. So with the weight here, we mean that, let's say if we have a server with 16 GB of RAM and 8 virtual CPU, and we have another server with 8 GB of RAM and 4 virtual CPU, then here obviously the first server has a higher configuration, so this can be inferred as having higher weight than this one. So now according to this, the load get distributed, that is, the number of requests going to the server 1 will be more than compared to the second server. Okay, so the next algorithm we have is the least connection. So in least connection, the load get distributed on the basis of the number of active connections on the server. So the server having the lower active connections will get the higher priority than compared to the other server which is having the higher active connections. So the load keeps on changing or will get distributed on the basis of the number of active connections on the server. So having the lower connections will get the priority than compared to the server having the higher active connections. Okay, so as the connections will keep on changing, like once the request completes, the connection gets dropped, and on that basis the load will get distributed. So here it's like a weighted round robin, but the difference is in weighted round robin the distribution was happening on the basis of the configuration, but here it is on the basis of the number of connections at a particular point of time. Okay, so that's the least connection algorithm. The next algorithm we have is the IP hashing. So this is again a very important load balancing algorithm that is used in many applications. So for example, in the e-commerce application. So what is the speciality of this algorithm is that it helps us to get these sticky connections. So what do we mean sticky connections? For example, let's say there is a user who is like using the e-commerce application, and he is like going through the application and adding the items to the cart. So if we want to maintain the state of the cart for that user session, And here, if we are storing those cart items on the server for a short period of time, then in that case we want all the requests sent by that user to be reached to that same server, because we are storing the cart details on the memory of the server. So if it goes to the different server, then there will be a difference in the on the cart items, right? So for such kind of scenarios or the requirements, we go with the IP hashing kind of algorithm. So that can also be seen in the banking applications, where for a transaction, in a transaction, the user logs in, then he'll verify, and he starts the transactions, update the transaction, and the transaction ends. So here, every step needs to be noted on, or needs to be checked before the next step is completed. So in this case, all the steps are maintained on the server's memory. So for such scenario also, we want all the requests should be going to a particular server. So for such scenario, here the load balancer will make sure the user's IP is hashed, and according to that, it will find the server and it will send the request to that server. So as the IP remains the same for that one session of the user, so in that case, all the requests will go to that particular server. So that's the IP hashing algorithm, and this is how we maintain or we get the sticky sessions. Okay, so that's the another algorithm, and the last algorithm we have is the geographic. So here with the geographical location, so this depends on from which location the request is coming. So on that basis, the load get distributed, or the load will be sent to that region or that server present in that region. Okay, so these are all the different algorithms that can be used, and there are many other in the list which we can explore, but these are the most commonly used algorithm for the load balancer. Okay, so next let's discuss why do we actually need the load balancer. So here I have just highlighted just 4 main reasons, but there are many other requirements that where we need the load balancer. So the first one is very high availability. So as we discussed in the initial example of ticket booking, so when we increase the number of servers, that automatically increase the availability of our system, right? So if we had only one server and the users gone or grown to a number where the existing server unable to withstand, in that case we increase the server and we distributed the load. That led us to high availability. So that's the first reason. Then we similarly, this is again the next one, that is scalability. So here, when we already know that we are going to get this much amount of load at this point of time. So for example, there is some flash sale, or we have developed a application of live streaming, like for a live streaming the cricket match. So during that, we know that for this period of time, this much or this is expected load. So for that, we'll definitely be ready, and we will be scaling our servers beforehand. So once we scale the server, we'll definitely need a component that will distribute the load among those scaled servers. So that's where we'll add a load balancer. So it gives us high availability, it gives us scalability. Then when these two are met, that will automatically impact the performance. So here it prevents any single server from becoming overwhelmed, right? So when we have multiple servers and when we have the load balancer in place, the load gets distributed and there is no one server that gets highly overwhelmed. So that's the another feature of the load balancer. Then we have the resource optimization. So that ensures every even distribution of workloads using resources more efficiently, right? So for example, if we go with the weighted round robin algorithm, then what does that will help? It will help us to distribute the load on the basis of the configuration. So that helps us to utilize the existing resource in a more efficient manner. So that's the another advantage of going with the load balancer. So these are the few common advantages or the requirements or the things that needs to be kept in mind for why we need to go for a load balancer. Okay, so next let's look at a quick demo of a load balancer. Okay, so let's look at a simple demo of a load balancer. So right now I have logged into the AWS console. So here let's create a couple of instances, is it instances, and then we'll apply load balancer on it, and let's check whether the load gets balanced or not. So for that, let me go to is it instance. So here let's launch an instance. Let me name it as server 1. Okay, so let's keep everything else as default. We'll use this image. We'll keep the configuration of that same. We'll go with this instance type that is eligible for free tier. So we just need it for demo. So we'll just go with this instance. And then if we don't need a key pair here, as I'll be logging into the instance through the browser. But if you want to log into this instance using a putty, then you need a key pair. So you can just create it. So let me just select. But yeah, we need to select one of the key pair to launch the instance. Then coming to network settings, let's go with the default VPC and default subnets, and let's go create a new security group, and we'll allow the HTTP and HTTPS traffic. Okay, so that's it, a basic configuration for our instance. So let's launch it. So let me just quickly create 2 more instances. Okay, I just created similar 2 more instances. So now we have total 3 servers, and right now they are just booting up. So by the time they just boots up, let's create a load balancer for them, and then we will run a simple Python script inside all of them that is going to return us the IP and the port of the on which it is running. So basically we are just exposing a API just for testing. Okay, so let's create a load balancer. For that, let's go to load balancer. Okay, so here let's click on create load balancer. So here we'll be creating an application load balancer. Let's click on create, and let's give it a name as demo load balancer. So it will be an internet facing, so that we can access directly from the internet, that is outside the VPC. We should be able to access this. Then the load balancer IP address, let's go with the default network mapping. Let's keep it inside our default VPC, and we need to select at least 2 availability zone inside this VPC. So here, what is the VPC, what are subnets, what are availability zones? So all these things will not be covering in this video, but if you are interested and if you want to dig deeper on this, I have created an Udemy course on this, that link I'll be providing in the description. So in that I have discussed end-to-end deployment of the microservices in a most secured manner, and in that I have also discussed all these things in detail, like what is VPC, what are subnets and all. So you can just refer to that if you are more interested into this. But here, yeah, let's go with default VPC. Let's select any 2 subnets in that, and then here with the security group, let's go with the default security group. Then this is the important thing that we need to select the configure, that is the target groups and the listener. So here, what is the role of target group? First of all, so the target groups make sure that it combines a couple of servers. So for example, if I created a first target group, so inside that I'll be having a couple of instances, and when we hit the load balancer, so load balancer will route that traffic to that target group based on the base of the port. So for example, I had the web is running on the port 80, so all the requests coming to the web will go to this target group, and it will load balance them among those instances. But I can use the same load balancer for some other set of servers by creating a different target group that are running on different port. So the moment the port gets changed, then the traffic will go to the other target group, and inside that it will just load balances among the instances running in that target group. So for this demo, I will be creating one single target group, and we will be putting all our instances inside that one target group. Okay, so let's do that. So right now here we don't have any target group, so let's create a target group. So the type of target group we need here is of type instances, and let's name it as demo target group. So here it will be listening on port 80, default port, and let's go with IPv4, default VPC, HTTP1, and health checks and all these things. Let's keep it as default. We'll not make any changes here. So let's go next, and here we need to select the instances that we want under this target group. Okay, so we'll just select all our instances that we have created. Among this, the load will get balanced, and we'll just include them inside this target group. Select next, create target group. Okay, so now target group has been created, and under the target group we have these 3 instances. Now if you go back and reload here, we'll get our target group. We'll select this. So like this, we can add multiple target groups, and we can able to use the same load balancer for different target groups. So let's keep everything else as default, and will not make any change. So you can just create the load balancer. Okay, so now we are good with the load balancer that will be listening on default port, that is HTTP port, that is on 80. So we don't need to add this, and it will be forwarding that to this target group under which we have our 3 instances. So now we are good with the creating the load balancer. So it is currently provisioning. So now that we'll just go back to our instances, and let's create a simple Python script that will expose a simple API, and then we can look at how the load gets balanced. Okay, so let me just log into one of the instances. So I can just select that, and you can just click on connect, and we can just connect it on this browser itself. So we can just click on connect here. So it will open the instance, and it will be logged in automatically. But if you want to log in using a putty, then we need that pair key which we created while creating the instance. So we can use that. Okay, so here first let me install the Python. Sudo yum install Python 3. Okay, so as you can see that the Python is already installed. That comes with this image, that is this instance image. so we don't need to do that. So now let me just Python file that way when we run, that will be running or exposing a simple API. Okay, so let me just create this file. Okay, so we have this file. Now let's run this file, python 3 app.py. Okay, so now we have started getting the response. So the script is running successfully, so we can test that by grabbing the public IP of this machine. And if we hit that, and we can see that we are getting a response that is hello from EC2, and we are getting the host name. So now let me quickly run the script in the other two instances, and then we'll look at how the load is getting balanced. Okay, so now you can see that in all the three instances, the script is running. So this instance 1, 2nd, and the 3rd. Okay, so now let's go back to our load balancer, and if we refresh this, we can see that the load balancer should be active, and here we got a DNS for this load balancer. So if we grab this DNS and go to the postman, and if we hit it, then you can see that first of all we are getting a response from one of the instance. So now if we repeat this, we'll see that the IP will keep on changing, so that shows that the load is getting balanced among these three instances. So now it is 32.36, so it has been changed to 42.197. Okay, so now it is 41.16, right? So internally it is getting load balanced. So that's a simple demo on data load balancer and what is the role of the load balancer that we have discussed in this video. Okay,